Okay, just to recap a little bit, there's two things that we want to do this week, 5.3 and 5.4. 2 days of 5.3, 2 days of 5.4. As soon as we finish the main chunk of 5.3, I can give you some homework, get you to practice. Tomorrow, I will give you the take-home assignment, which essentially it's basically on 5.3. If you're able to look at an equation and go to a graph, or take a graph and go to an equation, that's more or less all the only math part of that section. So what we're essentially doing it, we're studying for the assignment and we're studying for the test in doing this, okay? And I said before, transformations, going from left to right with your A, K, D, and C. You can do it that way, which is totally fine, and we'll do some practice. You can also do it a different way by logically approaching a sinusoidal, because as I said, a sinusoidal function repeats. So if you know how one cycle has transformed, you can essentially copy and paste it. So we're just going to focus on a single cycle. That's our goal. Okay? So you'll see, I'm just going to go through the typical step-by-step, AKDC method, talk about what that means. We do it once together. And then I'm going to take the exact same function. I'm going to provide an alternative method. I just loosely call it box method. It was coined by the person who showed me, namely my sister. And I'm like, oh, this really, really works. And it was faster. It was very efficient. But some of you might not want to learn something new. They're very comfortable with your normal AKDC step-by-step transformation. So it's up to you whether you want to adopt it or not. Either case, in both ways, you should be able to go in reverse. Like if I give you a graph, you should be able to figure out what the equation is. And I'll show you how we can do that. And I'll get you to do some examples in class, maybe do one word question in class. There's more textbook questions. You can do whatever. Tomorrow, we sort of wrap it up. And I show you a tiny short presentation of the assignment and what you need to do and so on and so forth. Okay? Wednesday, Thursday is moving on to 5.4 while you work on the assignment at home. Any questions before we begin? Okay, let's do it. Starting with, since we're doing transformations, I highly recommend you either figure out, you pull out some new colors. If you have pencil crayons right here. If you have highlighters, you can use highlighters. If you only have a pencil, think about solid circles versus hollow circles and dashed lines, solid lines, dotted lines, whatever way it works for you. I think it's in your best interest to draw the lines slightly differentiated so that it's not confusing when you look at it on a separate day. Okay? Let's do it. A step-by-step method. You know that. Okay, so let me go through the two different ways you can look at AKDC. For a sinusoidal function, you know that the A value is when you have a vertical stretch. However, since this is a sinusoidal function, the maximum is a 1, the minimum is also a -1. It happens to correspond with a value of 1. So if we have a value of 2, let's say, everything here is multiplied by 2, and your max and min also become positive and -2. It happens to coincide with what we call amplitude in physics when we talk about waves. How high we go from the axis and how low we go from the axis. So you can look at the A, the vertical stretch factor, in two different ways for sinusoidal. Same with horizontal compression. For a horizontal compression, you take all your x values and you essentially multiply it by 1/k. That could make something stretched or compressed. However, what's nice about sinusoidal is that we know what the period is supposed to be. If I stretch it, the period can become 4 pi, or period can become 1 pi, or anywhere in between or beyond, right? So instead of looking at the k value, we can actually take a look at how much distance we cover in a single cycle. There's different ways we can look at sinusoidal. Next. Okay, horizontal translation. Well, that's basically a shift. I know a sine function begins at the origin 0, 0, and it continues left and right. But if I say my sine function begins here, that sort of tells you how much I shifted, right? So you can look at a graph and be like, oh, I know what an original sine is supposed to be. Well, if it starts here, then it makes sense that I shifted by a certain amount. You can look at it differently for sinusoidal. And lastly, for a vertical shift, yes, you can take this entire graph and move it up and down by 1 or 2 or 3 or whatever. But because this is a sinusoidal, the curve always returns to that middle line. So instead of taking the entire curve and shoving it up or shoving it down, we could take that middle bar like it was a bench press and push that entire thing up and push that entire thing down, and it always has to go back to that line. It really depends on how you want to look at a sinusoidal curve. So, as I keep on saying, let's pretend it was just AKDC and we'll transform it. And then I'll offer you this box method and see if you like it or not. Your choice, what you want to do, but stick to one and just go with it. Okay? Here we go. Let's do some writing. For AKDC, for this function, notice how the k value is not factored out. I need it separated from the rest. So if I were to factor out 1 over 2, please be very careful not to make a careless mistake. Pi over 4 becomes pi over 2. How did I do that? Well, I'm dividing a half out from both terms. So it's factored. It's like the opposite of distributive property. Okay, so this is the curve I am trying to sketch here. Let's discuss. This has a little bit of everything. If A is negative, we have a vertical reflection about the x-axis. Amplitude. Notice how amplitude is always absolute value. Remember, for a curve, if I'm going up and down, I am not interested in whether I am moving in the positive or negative direction. I'm only interested in how far away am I from the middle line. So absolute value. So all right, the amplitude is a vertical stretch or compression by a factor of absolute value A. Okay, well, K is basically the same situation as A, but horizontal. So if K is negative, we have a horizontal reflection about the y-axis. Be careful here. Don't worry too much about this. I will talk more about how we can use this formula later. If we have our K value, we know what the new wave period is. If we know how large the new period is, we know what number we multiplied by or divided by. The K value is a horizontal compression or stretch, of course, by a factor of 1 over K. And I'm not interested in positive or negative because I've dealt with the reflection. Phase shift is again, horizontal shift, right or left. Okay. And yeah. And then vertical shift is obviously V shift up or down. Let's do this really quickly. Those of you who have everything copied. Fill out as much as you can. I'm just going to transfer my equation over because the next page doesn't have it. It's a -3 sine half x minus pi 2 minus 1. A, -3. K, 1 over 2. D, pi over 2. And C, -1. Starting, my base function, or parent function rather, is a sine. So you're going to see, let's do it in ones. So that's a 1, 2, and 3. There. That is going to be 1 cycle for a parent sine function. Okay. Let me keep that there for now. You don't have to do that yourself, but anyways, we have starting from 0, 0, and 0. Please note, I am expecting you to sketch a sine curve very comfortably without having to do any calculations from our previous lesson. Okay? I asked you to be very familiar with your sine, cosine, tangent, as well as the reciprocal functions. Okay? And it goes on forever, and it goes on forever. Sure. Why not continue this on? Remember, you can do this very lightly because as a parent function, you know this is going to change, right? I also want to draw your attention to the fact that this highlighted area is essentially copied and pasted everywhere else, right? It's the exact same thing. So we can just focus on one and copy and paste it anywhere else. All right, moving on. My first transformation is -3. I am going to take the liberty to do the, let's do fuchsia. Do the negative reflection and the multiplication of 3 at the same time. So 0 times -3 is 0. 1 times -3 is -3. 0 is also 0. And -1 times 3, -3 is +3. And 0 times 0 is 0. This. And again, you can do it very loosely. I don't want it to be so messy that you can't follow your own work. And that means this becomes +3, 0, -3, 0. There. That is -3 sine x. Okay. Next, your mental note, I should probably just do k value of 2. Because k value of half is going to make my period huge. Let me do the calculations down here. How about I use a blue? Period. Remember the formula that the new period is equal to the old period divided by k, which means the old period of 2 pi is divided by 1 over 2. In other words, 2 pi divided by 1 over 2 is the same as multiplied by 2 over 1. The new period is 4 pi. Right? I'm multiplying all of my x values by 2. 0 times 2 is just 0. Let me do an x. Pi over 2 times 2? Pi. Pi times 2? 2 pi. And then 3 pi times 2, or 3 pi over 2 times 2, it's going to be 3 pi, which is way far to the right. I don't have any space. Mental note, I should probably do a smaller grid for next year. Again, just very loosely, it should be like that. And on the left side too, negative pi over 2 times 2, negative pi times 2, negative 2 pi. I have just enough space for one cycle, going up and going down. And so this is negative 3 sine half x. Now, in one go, I'm going to move that blue line to the right by pi over 2 and down by 1. Right pi over 2 means moving to the right by 2 boxes and going down 1 box. Let's use black. So this x, 2 boxes, 1 box, right there. This x, 2 boxes, 1 down. 2 boxes, 1 down. 2 boxes, 1 down. 2 boxes, 1 down, somewhere there. Let's use a much thicker line. And do your best. Okay, there it is. This is negative 3 sine 1/2 times x minus pi over 2 minus 1. I mean, it's annoying, but it works. For sinusoidal, though, me as a personal opinion of mine that transformations sort of suck. It's a little annoying, but there's a reason why we work so hard in polynomials to transform without having to do AKDC. But it does have its uses. Now, based on this, you can analyze all of it. I will offer a couple of equations that you can use, or formulas rather, but the transversal, aka the mid-axis, if our maximum is a 2 and our minimum is a negative 4, maximum of 2 and a minimum of negative 4, where's my midline? There's a formula for that. And you remember from grade 11? I feel like all teachers give it. I have never used it because I've always made mistakes. You're looking for the average of the highest and the lowest so that you can find the middle. That is your max plus your min divided by 2, which is, in this case, negative 1. Interesting. Is there a corresponding, or is there some kind of coincidence between the transversal axis and the equation? Chin scratch. Let's move on. Amplitude. Your teacher might have also given you a formula in grade 11, where if you want to find how far I go up or down, you essentially calculate the difference between max and min and cut it by half or divide it by 2. So your max, you find the difference between max and min and you divide it by 2. And of course, it needs to be an absolute value. So in this case, it will always be positive, I guess. 2 minus a negative 4, that's a positive 6. Divided by 2, it is a 3. Is there a coincidence between the 3 and the equation? Chin scratch. I hope you see it. pause video to answer a phone call. All right, let's keep moving on. So something, I'm gonna write it in red. Something you might notice is that the C, the vertical shift, is equal to the transversal. You might notice the amplitude is also A. Or sorry, the amplitude here is also the vertical stretch. The max and min we can calculate how? Just from visually. If I know the midline is right here, and I know what the amplitude is, that's right. So you can argue that the maximum is essentially take your C and you're adding the A, take your C and you're subtracting the A, whatever the absolute value is, of course. Right? Huh. Can we use this to our advantage? If this is not something that you need to memorize, if you're able to understand this without memorizing, you can use that to your advantage. And that's what I want to offer as your alternative for transforming functions. You're using logic. Ready? It starts off with the midline. So box method, let me rewrite this once again. And you could look at this as instructionals, but I think it might be easier to see it in action. -3 sine 1/2 x minus pi over 2 minus 1. All right. Oh, geez. I'm going to end up rewriting it. Y is equal to -3 sine 1/2 x minus pi over 2 minus 1. All right. I understand that I made a mistake. I gave myself a nice large grid. I gave you a zoomed in one. Once again, mental note, there's a lot to fix in this handout. That's my bad. If you would like, just watch. I will have this available online. And so if you really want to adopt it, the video as well as the handout that's online, you can use. Just listen and see if it makes sense. And if you like it, try to use it for practice, okay? Number 1. Sorry, step back. We are going to draw a box. It's the goal. If I told you that inside this box, I have to have a sine function, where would you put the dots? Inside this box is one cycle. Where would your 5 dots go? Give me one. Starts at the middle. I like the idea. Start. I'm going to use that word. Okay, starts at the middle. Give me more. Good. It will go somewhere here, but I don't know where. I need some other reference here. Can we do some more about that midline? Something else? Zach?
Should have another dot in the middle.
Right in the middle, right? And then at the end. So somewhere between the start and the finish, somewhere here. And then between the first 2 dots, I should have something on top, hitting the top of the box. And between the last 2 dots, I should have another dot hitting the bottom of the box. And if I have those 5 points, I have this. And then I can copy and paste everywhere. That's the goal. So let's see if we can figure it out logically based on this equation. Where's my midline? Don't look at the first page, look at the equation. Where's my midline? Sorry, Setcast, -1. Let's draw this out. Good. From there, we should be able to draw out the roof and the floor of this box. What else can you tell me from -1?
It has an amplitude 3 and it's reflected on the
Amplitude of 3. That's right. Yes, and it's reflected. Keep that in the back of your mind. It's reflected, okay? But I do know that my roof has to be here because that's 3 above. And my floor has to be down there because it's my 3 below. Now let me use a different color. Bless you. Where am I starting? Where am I starting? So I've done this. This is in green. These two are in green. It's done. Yeah? Remember, a sine curve is supposed to start at 0, 0. If I shifted pi over 2, then I am starting there. Right? So you can assume that number corresponds to your start of the box. And here's a tough part. Where do I end? In other words, how long is my one period? How long is my one cycle? Always, old period is always 2 pi. My k value is 1 over 2, which means 1 over 2 pi divided by 1 over 2, 2 pi times 2 over 1. So with my blue line starting at here, I need to count out 4 pi, and that's when my box ends. So 4 boxes is 1 pi. So to count out 4 pi, I need to count 4 times 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here's the end of my box.
Can you repeat how you got that?
Which one?
The end.
The end? Sure. Were you able to calculate 4 pi?
I wasn't really focusing when you were saying that.
So, but were you able to calculate 4 pi?
Yeah.
Okay. If I know 4 pi is how long it takes to cover one period, okay, one cycle, and I know that I have to start at pi over 2. So from pi over 2, I essentially counted out 4 pi. So when I do so, notice how 4 pi is here. I just added an extra 2 boxes on top of that. It sort of makes sense, right? Now, if you don't see it, here's my box. It's a sine function. Where do I start? In the middle. It's a sine function. Where do I end? In the middle. And start and finish, there is another point on the transversal right in between. Bless you. 1, 2, 3, 4, 5, 6, 7, 8. Next. Normally, I have a maximum here. But I told you to keep that in mind. Which means I start with a minimum and then I go to a maximum. And if I have this, I can cut and paste and do all the other parts. But look at the parallel between this one and that, okay? Starting from pi over 2, it goes down and comes back up at 5 pi over 2, which is right there, 5 pi over 2, and then it continues up. Unfortunately, you don't see it. So henceforth, next year, I'll try to make it more convincing. But how you want to do it is up to you. If you understood curve sketching with sinusoidal last year, you might see the efficiency in this quite a bit. If you don't, that's okay. You can still analyze graphs based on what you're given. Question, just surface level questions. Yes,
So our D value is always the starting point.
you can say it that way, yeah. But here's another question then. What if, since you're repeating this, can't you argue that you can technically start here? Absolutely. Absolutely. But your equation would change. Your equation could be a little bit different than what I gave you, but it still represents the exact same curve. So when there's a test question, there's a good chance that I'll have to go through everyone very carefully because there's more than one answer. Right? So that's on me. But that's okay. Question?
You said about the C value that has to go back onto the like original axis or something?
The transversal?
Yeah.
Mm-hmm.
What does that look like? At the beginning of the lesson, you said that if you have a C value that shifts it vertically, it will like eventually go back to its original.
Well, consider what we have here. My mid-transversal is not at 0, 0. It's not at y equals 0. The curve always returns to this new green dotted line, right? At no point is it doing this and then start like doing that again. It's always going to stick to that line. So if you think about like that, as long as you know where that midline is, if I raise that midline, the entire curve has to go with it. Right? Sort of like a corn dog, I guess. Does that make any sense? Does that make any sense? No? You raise it, it goes with you?
I thought it was the opposite, which was it will eventually go back to its original.
No. So yeah, actually, you know what? That's not a bad example. Here's the corn dog stick. No matter how big or small, it has to follow that stick. Okay, now we're getting creative here. Okay, the ketchup and mustard stuff going. Oh man, now it's getting all messy. But you get what I'm saying. Whatever method you choose, it's really up to you. Okay. What do we want to do? We have 30 something minutes left. I do want to get to some of these word examples. You know what? This is a good time to see which one you prefer. Going backwards, here's an equation, right? And this equation draws a graph like so. I did not tell you if there's a sine. I did not tell you if it's a cosine. It's up to you to figure out what the A, K, D, and C could be based on sine or cosine. But whatever you choose, I want you to go back and do the other function as well. My recommendation, just for our class purposes, let's start with cosine. In other words, let's pretend your curve has to begin at a maximum or a minimum. Try it. Whether you want to do this in a transformative way, whether you want to do this using the box method way, it's up to you. But see if you can create an equation using this as a cycle. Okay, I'll pause the video and give you a chance. About like 3 minutes. I hope I didn't miss much. Sorry. I don't know how much I skipped in the recording. Totally forgot. So it is what it is. We use a formula for mid-transversal. We use a formula for amplitude. We're using the little formula to calculate what K is. And so we plugged in everything, but we don't know what D is. What is D? Where are we starting? And that's up to you. Suggestions? Yep. Start at the top. So I'm going to pretend my cosine, which started at the y-axis, was pushed to the right or shifted to the right by 3 pi over 8. Very simply, my horizontal shift is 3 pi over 8. And we're done. Let's say you were a bit of a, you went the path less trodden, and you said, no, can I pretend my cosine curve starts at a minimum over there? Well, absolutely. What would that look like? Well, your y value is there. I have a cosine, and the amplitude is a 2. My k value is still 2. and I move to the left, in other words, negative pi over 8, my d then would look like a positive pi over 8 minus 1. Please be careful. That difference right there of a quarter period, because I am starting at a negative, I have to communicate that it's flipped upside down. So the d value can accommodate for a positive a. The d value can also accommodate for a negative a. Just have to make sure you have got it correct. You have matched it correctly. And that's it. I guess I'll pause the video again. Would you please try to pull out an equation of both sine and cosine for this one? Okay. I would recommend, just as we did before, start with the cosine and then see if you can use your analysis to pull out an equation for sine as well. I'll pause the video once more. All right, I see a lot of murmuring, and I'm hoping that it's because you're discussing whether you got it right. Here's how I'm going to do it. Just as usual, my mid-axis or transversal, let's call it transversal this time, is going to be from 5 to negative 1. So 5 plus a negative 1 divided by 2, it's going to be 2, which makes sense, as there's my dotted line. My amplitude is going to be, so absolute value, is going to be 5 minus a negative 1 over 2, which is 6 divided by 2, that's 3, which makes sense. Next, what else am I doing? Oh, period. So my k value is my old period divided by new period, which is 2 pi divided by, let's see, negative pi over 2 and then positive 7 pi over 2. Together, I traveled 8 pi over 2, which is 4 pi. Right? Yeah, which means my k value is going to be 1 over 2. Lastly, my d, my shift, it depends on where I start. Anyone have a suggestion of where they would like us to start? Bottom? Someone, you want to do this one? Oh, Nathan, what about you? Top? Both are fine. How about I start by talking about this equation, and then I'll give an alternative because they're both just as correct, and then I'll quickly change that into sine. Okay? So here, the point is given, my shift is a positive 3 pi over 2. And since this is cosine, I can pretend that there is no vertical reflection. Here we go. My equation would be y equals positive 3 cosine k value of half x minus a 3 pi over 2 plus 2. If you decided to go with a minimum, you would have gotten something along the lines of a cosine with 1 over 2, and my shift is a positive pi over 2. However, because my shift is with my negative, I have to show that a vertical reflection has happened. So either or any proper variation of these. So in other words, coterminal, okay, if you think so, coterminal functions of these, totally good, absolutely acceptable. This is just as correct as if I shifted to the right by 4 pi, so 8, 11 pi over 2. You could have just as written here 11 minus 11 pi over 2, and you get full marks because it represents the same function. If you were to do sine, let's pretend I am starting right here. I'm going to pretend that's my start. Perfectly in between negative pi over 2 and positive 3 pi over 2. If I were to do this as a sine function, I would have 3 sine 1 over 2, because that doesn't change, x. I move to the right by a single pi over 2 plus 2. Notice how the only thing that's different between a positive 3 amplitude, k of half, c value of 2, c value of 2 is a shift of a quarter of a pi. Question and question.
I did that too, but it's a little off on decimals, and I think it's because distance of half of the half to find how much it shifts. Like the second time you do half, it's not exactly half, if that makes sense. The way I did it, yeah, so I found the difference between the point just left of the axis and then the point just right. I found the middle between those, and then I found the middle between those. And that's 5 over 2. But I think like the middle between that point and the one to the left isn't quite but it's not right. If you put that equation into decimals, it doesn't. The intercept isn't at 0. Like it's not on the word, but it's just right before.
Yeah, I would say that it's true. That's not quite 0, 0.
So that's fine.
No, I mean the picture is not accurate. I mean, it looks like it's at 0, 0, but I wouldn't be surprised if it was more just slightly to the right of it. And the origin was like right there, slightly off. It wasn't intentional that it was supposed to hit 0, 0.
Oh yeah. Right.
Yeah.
Okay,
Yes.
Would it work if I like took 3 pi over 2 and added half of 2 and then shifted it by that?
If you took 3 pi over 2 and added half a period?
Oh no, a quarter of a period.
Quarter of a period. Just yes. So the question was, let me give me a sec. 1 over 2 x. Let's pretend I went here. That would be the halfway point, negative 3 pi over 2. So that's a plus 3 pi over 2 plus 2. Okay, the question was, is it okay if you go from cosine to a sine by shifting it a quarter of a period? And that's something that you made a connection to last year. And the answer is absolutely. But please be careful. A quarter of a period is not always 90 degrees. Notice because of the stretch, a full period is no longer 2 pi, a full period is 4 pi. So if you're going to use the shortcut method and just deal with the shift, right, and add a quarter period, you have to make sure you know what a quarter of that period is. Is it a quarter of 2 pi? Is it a quarter of 4 pi? So on and so forth. So if you know and you're not going to mix yourself up and you've taken everything into consideration, you can keep all that in your head. There's absolutely no reason you can't. You should be able to, you should feel comfortable doing that, in fact. But if you're not quite sure, or if you're still getting the hang of these transformation or box method or whatever, don't make the careless mistake. Just stick to the plan. Yes?
Also, are you getting your tests back?
I've been told to hold it until Wednesday for some reason. No, to tomorrow. Tomorrow. I've been told to tomorrow. Assignment I can give back. I was supposed to give back to the first class. I forgot because I was, yeah. All right, everyone. One thing. I want to give you an example and I want to get this sort of through. And I also want to give you that opportunity to use, you know, transformations or the box method, whatever way you choose. I'm going to ask you to consider, number 1, more physics style. Number 2, a Ferris wheel question that you probably did last year. Or number 3, a little more progressive towards the assignment that you might get tomorrow. Okay? What would you like to do as part of brushing up on grade 11 skills? Number 3? Number 3? Number 3? Okay. Try it. Okay. Tide. The tide rises, the tide falls based on the turning of the moon and whatever. Okay. It rises at 1 a.m. Its tide is low at 2 p.m. So notice I intentionally made it a little tricky. You know what? Can I change this? How about we turn it into, should I turn it into a 24-hour cycle?
Yes.
Yeah, is it easier that? Okay, for now, let's pretend this is 1 p.m. I intentionally did 2 p.m. just to force you to like not cheat, right? Not take shortcuts. Let's do 1 p.m. to 1 a.m. to 1 p.m., high tide and low tide. Draw a sketch representing the height of the water beginning at midnight. So 00 represents time at midnight, okay? Try to sketch it, and from your graph, tell me the amplitude, period, location of transversal, write the height of the water as a sine and cosine. Please leave this until maybe 5.4. You don't have to do part D. Okay. See if you can do number 3, and I will do that on the blank piece of paper. Okay, I'll pause the video one more time. Okay, while you're working. 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 4, 5, 6, 7, 8, 9, 10, 11, and that's 12 p.m. That's 1 p.m. Okay, the question also says 15 meters high tide at 1 a.m. So 15 meters. Something like that. So 3 that's a very strong color, okay? And at 15 okay. Okay, based on this, that's all they give you, huh? That's fine. We have a max, we have a min. The transversal is max plus min divided by 2, which is 18 divided by 2, that's 9. 3, 5, 6, 7, 8, 9. Okay, so here is my transversal. Something along there. We have my amplitude, which is max minus min divided by 2. That's going to be a 6. And then let's assume, just as the question says, I start here, and then that's my high to low. So it tells you an idea of how long my cycle is going to be. Period. New period is old period divided by k, or k is divided by old over new. We know that the old is 2 pi. And we also know that half of a cycle is covered here. So 1 hour, 2, 3, 4 hours, 5 hours, 6, 7, 8, 9, 10, 11, 12 hours is half of my new period. So my new period would be 24 hours. So in my equation, my k value will be pi over 12. I know, we changed the question to make it easier. But yes, you're right. It would be pi over 13 if you did it originally. Okay. And I think the answer key that I put online is also pi over 13. So you're not wrong. Yep, it's still running. Yeah. So we've got transversal with that, and we're starting at 1 hour, right? So with this, I think I have enough information. My height of the tide is equal to cosine. Since I'm starting at maximum, I'm good. Amplitude of positive 6. Cosine. K value is pi over 12. X, I've shifted to the right by 1. And I moved up by a 9. I honestly find it's very simple if we think about it as a box method, but again, I'll leave that to you. If you have chosen to do this by sign, I think it makes sense that you try to create a halfway point. 1, 2, 3, 4, 5, 6, right here, to give you a better idea of where your sine curve might begin. So you can choose. You can pretend the sine curve starts there, or you could pretend the sine curve starts here, but you have to add a vertical reflection. Yes?
Wait, sorry, where did you get the value from?
This, the idea that my cosine curve started at 1 a.m. instead of midnight. The question said start the graph at midnight, so that means I must have shifted 1 to the right. And you might be wondering, Mr. Kim, how are you supposed to deal with that? That's not radians. But remember, by distributive property, that 1 becomes pi over 12. It becomes a 15 degrees. So it's like I shifted 15 degrees, but we have, thanks to the k value, we've converted 2 pi into a cycle of 24. So 1 out of 24 is like saying 15 degrees out of 30. Yes?
I'm kind of confused why you're able to like use radians and the unit of like time to calculate your k value or your series.
Well, it's a good question. Originally, this has to be a range, typically 2 pi, right? It goes from 0 to 6.28, let's say. What we want to do is turn that into 0 to 24 for 24 hours. By having this k value, we let the x value be in terms of hours, and then we'll take that period of 24 hours and it'll convert it into radians using the pi value, using the k, right? Because the pi value is in there. You can think about it like that. Sorry. Last one. I'm going to pretend I start there at the 7. It could be a -6 sine pi over 12 x shifted to the right by 7 plus 9. Okay? Think about what you can do for homework. All of these questions is all fair game. I know there's another handout, this loose piece of paper. We're going to do more of that tomorrow. If you want to get a head start, awesome. All the power to you. We'll continue this, and then I'll present to you your assignment, please. Yes? No, you'll see. Just wait until tomorrow. We get a better understanding.
I'm going next Wednesday, Thursday, Friday, so I should write the test on Tuesday.
Good. I'd rather you write that. I guess. You can plan ahead of time, and I think I should do that.
Okay, I mean, I'll look for all the charges.
We'll talk. I'll figure it out by next week. Okay? Okay, that's it, everyone. Goodbye. Thank you for